Hey, Trigonometry. What I want you to do is take out your notes from yesterday. We're just going to finish up a couple of the things that we did not do in class in our notes, which was some factoring problems, and then maybe look at number 51 in our homework because that also involved some factoring. So if you look at number 2, this is an interesting one because secant squared minus 1 is already a trig identity. But the problem here just says to factor. So you have to bring back how to factor. Secant squared minus 1 is the difference of two squares. So you could think of that problem as just like x squared minus 1. And if you were to try to factor that, you would have that as x minus 1 and x plus 1. And so the same thing would apply here. We just have secant squared instead of x squared. So this would just simply factor to secant theta minus 1 and secant theta plus 1. Now we do know that if we think back to the Pythagorean identities, right? I'm going to write those down. Sine squared plus cosine squared is equal to 1. And then we also have 1 plus cotangent squared is equal to cosecant squared. And we also have tangent squared plus 1 is equal to secant squared. Those are the Pythagorean identities. So if you were just looking at this number 2 identity, you would also notice that secant squared minus 1 is just equal to tangent squared theta. If you were to simplify that, you can just see it right there. It's tangent squared. But if we're going to factor, just go back to the algebra and try to figure that out. Now, number three, we're trying to factor. If you ever have a problem like this, and this is going to show up in future sections as well, if we're trying to factor this, the problem with that is that we have a cosecant and we have a cotangent to start. So the first thing we want to do is actually use a Pythagorean identity to get all of these things to be common. So if we look up here, cosecant squared is equal to 1 plus cotangent squared. So the first thing I'm going to do is just substitute that in. So cosecant squared x would be the same thing as 1 plus cotangent squared x, right? And then you'd have minus cotangent x minus 3. I'm going to take that and just write that in, standard form. So this would be cotangent squared x minus cotangent x, and this would be minus 2. And so now we have a kind of a quadratic expression here, just like if we had x squared minus x minus 2. And if I were to say, how do I factor that? Right? You could factor that using the AC method, right? You're going to end up with double parentheses, and you're going to end up with, an x here and an x here, and a minus 2 and a plus 1 here, and then you have it factored. You're going to do the same thing here. So it depends on which factoring method you use. You can use the AC method on this one, and I'm going to go ahead and do that with the cotangent right in there. So if you use the AC method, okay, that means we could take the middle term. I'm just going to write this again. That means we could take the middle term right here and we can split it into a sum. And our AC is going to be, this times this. That's going to be negative 2. Just thinking about our A and our C value is negative 2. So we have to think about what multiplies up to negative 2 but adds up to negative 1, which is our B term. And so that's going to be negative 2 times 1, right? So we could split that term into negative 2 cotangent x plus 1 cotangent x. And then we would bring down the other terms. So cotangent squared x minus 2. And then we would group that. We'd group this, and we'd group this. And then we would pull out whatever they have in common. So in this first group, we have a cotangent that we can pull out. So we take out the cotangent. We write what's left over, which is cotangent x minus 2. And then in the second group, we don't really have anything in common besides 1. So I can take out a 1 and write that as cotangent minus 2 as well. Cotangent x minus 2. And so therefore our factoring would be cotangent x plus 1 and cotangent x minus 2. Cotangent x plus 1 and cotangent x minus 2. There's our factoring. And there's our answer. Now, if you don't like actually doing the whole factoring and AC method and having to keep on writing cotangent and all that, you can just do a little substitution, kind of like what I did right here, and just rewrite that and just make it simpler, just to factor it. You can just write that as, x squared minus x minus 2, and just pretend that cotangent is just an x term, factor it, and then you'd have to kind of resubstitute cotangent into this expression. You can see those are like the same form, so you could do it either way, but my final answer is this right here. All right, so kind of applying some of that factoring to the homework that you might already have done, but number 50 and 51 are some examples where you have to factor and then simplify. So just going through a couple of these. Number 50, you could factor this because the top here is your classic difference of two squares. So cosine squared minus 4, you could write this and factor this to cosine x minus 2 and cosine x plus 2. Okay, because that's the difference of two squares. Divided by cosine x minus 2. And so if you have that, cosine x minus 2 cancels with cosine x minus 2, and you're left with cosine x plus 2. If you look at number 51, this would be an example where you could use the AC method again. Now, this is a little bit different because your trinomial here that you have is not quadratic. It's something raised to the 4th, and then it's squared and 1, so it's a little bit different, but you can still factor this using an AC method. So what I'm going to try to do here, the a times c in this problem is just 1, right? Because this is a 1 times 1. So I can take this middle term and I can break that up into a sum, right? I want to try to add to 2, but I want to multiply to 1, right? So I can just basically say 2 tangent squared x. That's going to be the same thing as just 1 tangent squared x plus another tangent squared x. The only difference here is that when you are splitting this middle term, right, that my two terms are going to be squared, because since my whole middle term is a tangent squared, obviously when I add up to 2 tangent squared, I have to have 1 tangent squared plus another tangent squared. So that's the really only difference there. So we're going to bring down the first term, tangent to the 4th x, and then a plus 1. We really can just do the same thing that you do in factoring by, grouping. We're going to take this and group it. We're going to take this one and group it and look to what's in common. So take out the GCF from this, which would be a tan squared x. This would be tan squared x with a remaining tan squared plus 1. And then the second parentheses would just be plus 1. There's nothing you can take out there, so I'm just going to put a plus 1 there. And then that would just obviously remain as tan squared x plus 1. So when you factor this, this just becomes tan squared x plus 1 times tan squared x plus 1. And when you're looking at this problem, remember tangent squared x plus 1, that is a trig identity. So if you look back on what I had written down here before, right? Tangent squared plus 1 is equal to secant squared. So since that came out of that problem, we can just substitute in a secant squared. And so this we could write as secant squared x, and then this could also become another secant squared x. And if I take squared times squared, that's going to be to the fourth. So that'll be secant to the fourth x for number 51.